Hello, YouTube. Today we're going to talk about tabular neural networks for individual claims reserving. This is a very specialist topic in actuarial research, but it's one that I have a personal interest in. The links to those notebooks are in the description below. So what is this all about? Well, we're trying to predict the future claims development based on data that we have about the claims. And we're going to use a tabular format for our data, and we're going to use neural networks. Neural networks can be quite flexible, and it doesn't have to work with a tabular structure. So there's alternative architectures that you can try that aren't in a tabular format. You can, for example, use a sequence-based models, such as GRU or transformer-based structure. But here, we're going to use tabular-based networks. We're going to use PyTorch for this. PyTorch is a popular package for doing neural networks in Python. A lot of research is done in PyTorch, so we're going to give it a go. So we'll just define our packages. And the first step of this notebook is to just import our packages and then import our data. We will then transform our data into a specific format where you have, after a bunch of transformations, you would have a training data set where you've got some basic information about your claim, and then you would try to predict the future records where the response variable is either payment size or payment inflated. This is very basic, and the question that's been posed to the working party is, can we transform the data structure to make it more predictive? We have your very standard train and test splits, and then we use scikit-learn. Scikit-learn is a fantastic framework for modeling tabular data. It has a number of different tools, and as long as you set up as a scikit-learn regressor, then you can plug right into things like cross-validation, holdout sampling, and pipelines, particularly, are very useful. So here, this all very long boilerplate is a setup that plugs in your neural network module into a scikit-learn regressor. There are pre-existing packages that can do this, such as Scorch. However, I customized this class to be exactly how I wanted it to be. You may get better results from changing the parameters. So all this stuff happens, and we've also got some interesting holdovers from some of our previous articles, and then we just plunge right in. We tried different neural network structures. So here we've got a very simple one being just a log length GLM, the simplest as you can get, almost, with a neural network style structure. We do a feed-forward model, we do a ResNet, we do a DenseNet, and we try some multi-layer models as well. We then can plug that into a scikit-learn pipeline where we apply transformations before we do the model, and we give it a go. So we try a few different things, and then we get some results. We then compare the results and see how we go. And then you can plot the results and see how the different models behave. And then that's the first article. In the second article, it's pretty similar, but we just try a different data structure. So here we've done some further transformations, which has interesting ideas, but also interesting limitations. I'd suggest just reading the book to check it out in full. And then we've once again plug into scikit-learn and see how things go. The boilerplate is slightly different. I've made some adjustments there, and we've got the neural networks just like before. Then with the results, once again, we check it out, and we see how the different models behave. Pretty simple. So where I'd like to go with this is just a starter kit. I was hoping for the research group and anyone else who might be interested to play around with different structures, try different validation techniques. There was a whole host of ideas in our email list of things to try. This is by no means cutting edge research, but for those readers at home, I also hope it gives some introductory information around how you could build a neural network and use it to predict your claims reserving. Whether or not this provides a better model than other things that you can plug into scikit-learn remains to be seen. Thank you all for listening and have a good one. Bye.